In problem 10.2, we are given 6 different polynomial functions and asked to find some information about them. We're then going to sketch a graph and eventually check if our graph is correct using Desmos. Now, I have selected 3 of these to look at in this video, and then I'm going to leave the other 3 for you to try to kind of see how things are going. And remember, you're going to use Desmos to see if you got it right. So, the stuff they want us to find about these polynomials: the degree, in other words, what's the highest exponent, all of the zeros, and then they want us to talk about its end behavior. So specifically, we're going to complete a sentence that they gave us a sentence starter for. So first, let's look at the polynomial function a of x. In this, to find first of all the degree, we need to check how many times is x being multiplied together, because that'll tell us the highest power of x. So I've got x times x times x. I don't need to find the rest of the polynomial. That's going to give me x cubed, which means that I'm going to have degree 3. And they all have, remember, those invisible 1s in front of them, so it really is just x cubed. There's no 2 in front, there's no 12 out front, anything else, just x cubed. And for the zeros, we are going to have, we just look at each factor and do our quick calculation. So the x plus 2 is going to give me a 0 of x equals negative 2. X minus 2 is going to give me a 0 of x equals positive 2. And x minus 8 is going to give me a 0 of x equals 8. Now for the end behavior, I want to point out one other thing here. Remember, we have x to the third, so we have an odd degree, and we have an invisible 1 out front, so we have a positive leading coefficient. That means for an odd degree and a positive leading coefficient, our end behavior is going to look like this: down on the left, up on the right. Which means if I finish this sentence, as x gets larger and larger in the negative direction, y gets larger and larger in the negative direction as well. Remember, as we go off the left side of the graph, we also go down on this one. So now we're going to try to sketch this graph. So I'm going to start with some definitive points we know. We know we have an x-intercept of negative 2. We know we have an x-intercept of positive 2. And we know we have an x-intercept of 8. Now, one thing we haven't talked about yet, but that's actually important here, all of those have multiplicities of 1, which means that the graph is going to go straight through all of those x-intercepts. I'm also going to throw my end behavior on here. It's going to go roughly like this. And then from here, we just kind of connect the dots. It's not going to look perfect, and we're not calculating any exact points really, other than our x-intercepts. But roughly, our graph is going to look like this. So let's go over to Desmos and see how we did. X plus 2, x minus 2, x minus 8. So there's our polynomial. I'm going to zoom out a little bit so we can see it better. Now, some of the parts are taller than we drew on our graph, but let me make this a little bit bolder. There we go. We can see there are x-intercepts right there, the 3 that we found. The graph goes straight through at those locations, and everything seems to kind of line up with what we expected. It goes, when we go off the left side of the graph, so that's over here, we're going down, down, down. When we go off the right side of the graph, we're going up, up, up. So everything seems to agree. On to b of x, and we got to go through a similar process here. Now, a couple things I noticed right off the bat. This x minus 2 is squared, which means if I want to rewrite this equation, I can think of it as negative x plus 2 times x minus 2 times x minus 2. I'm just rewriting that to make it a little clearer what my degree is going to be, because now I have x times x times x. I have 3 things being multiplied together, which means I have, again, x cubed, although this time I have a negative out front, so it's negative x cubed. So my degree is still 3. My zeros here are going to be x equals -2, x equals +2 from these first two factors, and then x equals +2 again. So I'm just going to make a note here that this x-intercept has a multiplicity of 2. That is even. That tells me that this is going to be a bounce on my graph. When I hit that x-intercept, I'm going to bounce off, not go straight through. For the other x-intercept at -2, I am going to go straight through the graph there. Remember, there's that pattern we saw in the first problem. It still holds up here. For our end behavior, remember we did this last class, we have a negative leading coefficient, right? That's invisible -1, and we have an odd degree. That means our end behavior looks like this. It's the opposite of what we had last time. On the left side, we're going up, and on the right side, we're going down. So to finish this sentence, as x gets larger and larger in the negative direction, y is also going to get larger and larger, but in the positive direction. It's going up. Y gets larger and larger in the positive direction. And I'll apologize for my handwriting, as I usually have to do. So let me sketch our end behavior onto our graph here. It's going to look something like this. All right, we found that already. And then we're going to go ahead and sketch our curve. Now remember, when we get to that green x-intercept there, we're going to bounce off because it is an even multiplicity. So here I'm going straight through. Here I am bouncing like it's a parabola, like it goes bouncing right off, and that's the vertex. And that also lines up with the end behavior. If we went through the graph there, we would end up here, and that's not where we want to be. Let's go and check our graph on Desmos here. So we have -x + 2 times x - 2 squared. And there's our graph. We can see there's our x-intercept, and we go straight through at -2. Here's another x-intercept at +2, and we bounce off. Right, back to our last problem. Polynomial f. So, first thing we want to check out here is what are we going to end up with for a leading term? Because that's going to help us find our degree and our leading coefficient. I notice on this one I have x to the third power, which means this is x times x times x times x + 4 times x - 3 times x - 3, because it's squared. So I notice if I were to multiply this all together, which I'm not going to do, but if I did, I would get x squared, x cubed, x to the 4th, x to the 5th, x to the 6th. When I multiply all those x's together, there's 6 of them. So my leading term here is going to be x to the 6th. And there's no negative signs thrown in there in the front, so it's positive. And there's also no numbers thrown in front of those x's, so it's just 1 x to the 6th. Which means my degree is 6. For my zeros, I have x equals 0 is what we get from the x cubed, and that's going to show up 3 times. So I'm going to make a note here. This has a multiplicity of 3. I also have x equals -4. That only shows up once. And then I have x equals +3. And that one has another multiplicity. That has a multiplicity of 2. I'm going to use a different color for that one. So I know on my x equals 0 x-intercept, the green one, that's an odd multiplicity, so I'm going to go straight through. Whereas my x equals 3 x-intercept, that's an even multiplicity, so I'm going to bounce off. And then for the x equals -4, that's just a multiplicity of 1, so that's what we're used to seeing. It goes straight through there as well. End behavior. In this case, we have a positive leading coefficient and a even degree. So this end behavior is both sides go up, which means if I write our sentence here, as x gets larger and larger in the negative direction, y is also getting larger and larger in the positive direction. Y gets larger and larger in the positive direction. So let's sketch this graph here. On the left side, we're going up, up, up. On the right side, we're going up, up, up. And then for my red x-intercept, I go straight through. For my green one, I go through. But remember, it's a multiplicity of 3, so it's going to kind of look like it's a cubic function, not a straight line. So it's going to do a little curve there. Now, for multiplicity of 2, because remember we still have to come back down and hit this orange x-intercept, this one is a bounce. So I bounce off. I don't go through it at all. And we end up with a graph that looks something like this, which is a really strange looking graph, but let's head over to Desmos and check it out. I think we'll find that we did this correctly. We have x cubed times x plus 4 times x minus 3 squared. That was it, right? Yes. So we can see we actually did this correctly. Here is our negative 4x intercept. We go straight through. We come down to the bottom, we come back up. Here is our next x-intercept we're coming up on, and you can see there's our cubic looking curve, our x cubed looking curve. It has that kind of bend in it. And then when we come over to here, for this last x-intercept, we bounce off. We don't go through it at all. And you can see our end behavior is actually correct. On the left side, we go down, down, or sorry, on the left side, we go up, up, up. It's a little hard to see. There is actually a bottom there. Zooming out's not really going to work well. On the left side, it goes up, up, up. On the right side, it also goes up, up, up. So we tried out 3 graphs here together. I'm not going to do the other 3 because this video is already getting plenty long here, but you do have those you can check out on your own if you want to try out a little more of these problems.